Okay, in the last video we found the velocity of point B, and in this video we are going to be doing the acceleration. We're going to finish this question up, and since the formula is already positioned right here, makes no sense to rewrite it, so let's note a few things. This right here we would consider the acceleration Coriolis, and this right here, whenever we're dealing with two-dimensional problems, this would be considered negative w squared p b relative to a. And let's cancel a few things as well. Notice that since point A and B are on the same body, the acceleration, the Coriolis is 0, and the relative acceleration is also 0. And since position A is fixed at the ground, this is also 0. And we can conclude that the acceleration of B is equal to the angular acceleration crossed with the position of B relative to A minus the square value of the angular velocity multiplied by the position vector of B relative to A. And if we find the acceleration, which is 5 radians per second squared clockwise, since it's clockwise, that's going to be a negative value. So I'm getting that from up here, and that's going to be crossed with the position vector, which is positive 3 inches times the direction cosine 65, 3 sine 65, and 0, minus w, which is 10 squared, multiplied by the position 3 cosine 65, 3 sine 65, and 0. Okay, so we can recall that this is just the determinant. The cross product is just a determinant. So let's do that determinant right here. I, j, and k. 0, 0, negative 5, 3 cosine 65, 3 cosine 3 sine 65, and 0, minus 300 or plus negative 300 cosine 65 minus 300 sine 65 and 0. Doing the determinant, we will find that this is equal to 13.59 negative 6.339 and 0 added to 300 cosine 65, 300 sine 65, and 0. Now if we add these two vectors up, the acceleration of B ends up being 13.59 minus 300 cosine 65. That is negative 113. And we get negative 6.339 minus 300 sine 65. We get negative 278 and 0 inches per second squared.